Hello, sixth graders. Welcome to Chapter 13, your last chapter of sixth grade math. In this lesson, we will take a look at patterns in data and box plots. So these first couple problems are a bit of a review from last chapter, taking a look at dot plots and histograms, and looking at some patterns within those sets of data. Many lakes and ponds contain freshwater fish species such as bass, pike, bluegill, and trout. Jacob and his friends went fishing at a nearby lake. The dot plot shows the sizes of the fish that the friends caught. The lengths are rounded to the nearest inch. What patterns do you see in the data? So first thing we're going to be looking at to see if there are any gaps. And gaps are intervals that contains no sets of data. So in this set of data, we do have information that doesn't have any data, which is between 8, 9, and 10 inches. So we can say, yes, there are gaps, and it's between or from 8 to 10. So there were no fish from 8 to 10 inches long, and there were two clusters of fish. And a cluster is a group of data points that lie within a small interval. So where you see most of the points is considered a cluster. So over here we have this cluster and this one. So we have a cluster ranging from 5 to 7, and then again from 11 to 14. So there were two clusters ranging from 5 to 7 inches long and from 11 to 14 inches long. So again, gaps, missing data, clusters, where all the data is found on the dot plot or histogram. So let's take a look at a histogram. When we're looking at histograms, they will have peaks and they can also have symmetry. Some of them won't and some of them will. Erica made this histogram to show the weights of the pumpkin grown at her father's farm in October. What patterns do you see in the data? So first step, identify any peaks in the data. So we're going to be looking for the tallest bar. In the tallest bar, we only have one peak. The interval representing the greatest number of pumpkins is for the weights between 21 and 30 pounds. Second step, describe how the data changes across the intervals. The number of pumpkins increases from 0 to 30 pounds. So all the way from 0 up to 30, we have an increase. And then starting from 31 down to 50, we see the decrease. So that peak there kind of creates the increase and the decrease of the weights of these pumpkins. And lastly, describe any symmetry the graph has. So again, if you remember symmetry, we can fold things either vertically or horizontally. Obviously, in this case, we'll be folding them vertically. And we're going to see if both sides of our peaks match up to one another or closely can mirror one another. If I draw a vertical line through the interval for 21 to 30 pounds, so that's here, right? The left and the right side of the histogram are very close to being mirror images, so the histogram has symmetry. So nothing too crazy when we are looking at dot plots. We've got gaps and clusters. When we're looking at histograms, we have increases and decreases and symmetry and peaks. So there's some new vocabulary for you. Now we're going to move on to box plots. Box plots are a way of showing data, and it really focuses on the median. So the median, again, is the middle value or the mean of the two middle values when the data is written in order. So again, whenever we have to find the average of the two middle data points, it's because it's an even number of data points. Then there is the lower quartile, is the median of the lower half of the data set, and then you have the upper quartile, which is the median of the upper half of the data set. So we have this problem in 1885, a pair of jeans costs $1.50. Wow. Today the cost of jeans varies greatly. The chart lists the price of jeans at several different stores. What are the median, lower quartile, and upper quartile of the data? So first step is going to be listing the orders from least to greatest and finding our median. And yay, we have an odd number, so that is 42. No extra work for us. So our median is $42. Now we have to find the lower quartile and the upper quartile. And so again, you're just taking everything to the left of the median and finding the mean of those values, and everything to the right of the median and finding the mean of those values. So here they've nicely done that for us, and we can see that we have $24, $28, $32, and $35 is all our lower quartile. We're going to, since there is an an even number of data points, 28 and 32, we need to find the average of those two. So 28 plus 32 gives you 60. Divide that by the two values that we are adding together, and you get $30 as our lower quartile. And our upper quartile, again, even set of data points, so we must find the mean of the two middle points. So we have 50 plus 60, that gives us 110. Divide that by 2, and you get $55 as our upper quartile. Now we're going to use that information to work on creating box plots. A box plot is a type of graph that shows how data are distributed by using the least value, the lower quartile, the median, and the upper quartile, and the greatest value. Below is a box plot showing the data for gene prices from the previous page. So the lowest price of jeans was $24, and that's marked here as our lowest. Then we have our lower quartile, that $30, which is represented here. I'm going to abbreviate with an LQ. Then we have our median, which was $42. There it is. Then we have $55, which was our upper quartile. I'm going to abbreviate it with UQ. And then our greatest value, the most expensive pair of jeans, was that $75, which is marked there. So notice how we have 5 different points: the least, the greatest, the median, the lower, and the upper quartile. So now we're going to practice making our own box plot. The data set represents the ages of top 10 finishers in a 5K race. Use the data to make a box plot. All right, first step, we have to list them in order from least to greatest. All right, and we have to next find the median. So there is an even number of data points, so we need to find the two middle points and find the mean of those. So let's change this up. And so we need to find the mean of 23 and 25. 23 plus 25 over 2, which gives us 48 over 2, which simplifies to 24. All right, then the next step is going to be finding that lower quartile and that upper quartile. So lower quartile, and then fourth step, upper quartile. All right, so lower quartile, sorry. So last time we did not include our median. In this case, with the jeans, it was 42. But since we had to find the average, since we had to find the mean of 23 and 25, those are going to be included in our lower quartile and upper quartile. So now we're looking for the median within both of those quartiles. So we have our middle number as being 21. Sorry, this is getting a little sloppy. And then here, our median is 33. So we're including those because we had to use them within our median, and if we didn't include them, then we would just separate it from left to right of that median number. And last up is going to be plotting those points on our box plot. So the lowest one, we had 18. And our greatest value we had was 38. Then we are going to plot our median, which was 24. Lower quartile was 21. And upper quartile was 33. Next thing, we are going to connect our lowest to our lower quartile and our greatest value to our upper quartile. Then we're going to draw that vertical line of our median and connect those. Oh, that's terrible. Hold on. All right, somewhat better. It should definitely be more precise than that. Just a little bit challenging with the iPad. All right, and here is your 3 practice problems. They're located on page 715 in your math book. Enjoy the rest of your day.